Alright guys, this is Unit 8, Lesson 8, and this will be the last lesson of this unit. And today we'll be working with quadratic word problems. And since our last joke was so popular, we'll tell another one. This is another one of Carly C's jokes because she is so funny. It goes like this. Where would you find a dog with no legs? So think about that. The answer is actually kind of obvious and fun, but we'll move on and get back to it later. So we realize that we can now solve quadratics with a zero product rule as long as the quadratic is factorable when it's set equal to 0. Remember, because we want to make those factors equal to 0. So now we can model some real-world situations that involve nature, and we'll get to those later. This one's more geometry stuff, but we'll get to that. So in exercise 1, it says consider a rectangle whose area is 45 square feet. So we know the area. If we know that the length is 1 less than twice the width, then then we would like to find the dimensions. So we actually want to know what the length and width are. Part A says if we represent the width of the rectangle using the variable w, so that's kind of like a let statement saying w equals a width, then write an expression, and it really is more of an equation to represent the length of the rectangle L in terms of W. So saying that L is equal to what in terms of W means to put W in your little expression. So could you write something to represent the length using the information up here? So hit pause and give that a try now. Alright, so did you come up with something like this? Let's see, this is more of an equation, not an expression, but the length is equal to 2W minus 1. So the length is, see that means L equals, 1 less means you're subtracting by 1, not 1 minus 2W, so be careful there. 1 less than twice W means 2 times the width. Remember the width is W. So here is your let statement for the length, and here is for the width. Now, set up an equation that we could be used to solve for the width based off the area. So if we're trying to find the value of variables, we need to write some type of equation. So could you write an equation based off this information to help us solve for our variable w? So go ahead, hit pause and give that a try now. Alright, well if you remember, you should know that the area of a rectangle is length times width. So if you just took the length here times the width, that would equal the area, so you would get some type of equation like this. So the width times the length, and you could switch them either way, equals the area. And again, you could have these swapped. You could have the 45 first and this over there. But see, now this would be some type of equation we could solve. So now solve the equation to find both dimensions. Why is one of the solutions not viable? So I'll help you out first of all. You should be able to recognize that this is actually going to be a quadratic because you could take this w and distribute it. And then from there, remember what we have to do to solve equations. They have to be factorable when set equal to 0. So go ahead and see if you can come up with the solutions for part C on your own. Alright guys, how did you do? So you should have started out, like I said, you distribute this here. And so we just distributed, came up with this is a quadratic equation because of the w squared. Now remember to solve these, you should always set it equal to 0. So just subtract 45 from both sides. And that's where this negative 45 came from because we subtracted 45 here. Remember, whatever you do on one side, you do on the other. Now look, this is set equal to 0. So now you should be able to factor this. And there's that scary leading coefficient greater than 1. So you have to remember how to factor that. And you did. Now, if you don't understand how this was factored, you need to go back and look at the factoring units. We've already taken tests on this, so you need to know how to factor trinomials. Then once you have them factored, remember take each factor and set it equal to 0, and just solve for that factor. So this one comes out to be negative 4.5, and then, that's everything. Now, not viable, remember, these are supposed to be the widths. And lengths in the real world could never be negatives. So if you get a negative answer when we're dealing with lengths, then therefore that is not possible. So then therefore we'll look at the other one, and that's why you end up with 2 answers sometimes. the other one doesn't make sense. So therefore the length is 9. So that was, so we solve for the width is 5 just by doing that. Then remember, take that 5 and plug it in up here, and then you can solve for that. And look, 9 times 5 is the 45, so you know you are correct. And this is just talking about why this is not viable. All right, if you need to, let's get more in there. Pause and fill in what you need to. All right, so exercise number 2. It says a square has one side increased in length by 2 inches and an adjacent side, that means next to, decreased in length by 2 inches. If the resulting rectangle has an area of 60 square inches, what is the area of the original square? So to help you out, he wants you to first draw some possible squares and rectangles to see if you could solve by guess and check. So start with one square, whatever it is, and then decrease one side by 2, increase the other side, which would turn it into a rectangle, and see what you get for the area. So just do this first part here. Come up with a square, turn it into a rectangle, and find its area. So hit pause and try that now. Alright, so his example, he just made a square where each side was 5. So if you added 2 to one side and subtracted 2 to the other side, that would make the condition and turn it into a rectangle. And if you found that area, we get 21, which is not 60. So it's not easy just to guess and check these. So we want you to show you come up with equations. So think about this. If the first square, we don't know the side, well, we would make this x and x, and then you could turn it into a rectangle. So start with your first square is x and x, and then come up with the resulting rectangle, and then could you write an equation and solve for it? So see what you could do with this exercise 2. So hit pause and give it a try. Alright, so again, like I said, you come up with a square. We don't know the side, so it's x and x. Then turn it into the rectangle somewhere. Oh, here we go. So you subtract 2 and you add 2, so you could still do this. Now we know that the resulting area of the rectangle is 60, so length times width would equal 60. So there's that equation. Then you would multiply this out. That's our FOIL there. Notice it's a minus 2 plus 2, so that's just going to be the dots. And then we have to, now there's 2 ways you could do this, okay? So when it's a single x squared with no other x term, then you could just actually get this x squared alone by adding 4 to both sides. And now we have x squared equals 64. And then if we want to solve for x, we just take the square root of x squared, which is just x. And remember, whatever you do to one side, you could do the other and take the square root of 64, which is actually 8. It's also negative 8 also, right? So negative times negative is positive, but we don't want it to be negative 8. It won't work up here. Now that's one way you could do it. So again, when you see an x squared and no other x term, you can just get the x squared alone. You could have also done it by, once you got down to this x squared minus 4 equals 60, you could do it the other way by subtracting and setting this equal to 0. So if I subtract 60, I get x squared minus 64, sorry for my pen here, equals 0. And hopefully you recognize this as a dots. So now I can just do x minus 8, x plus 8, and we'll still get the same answers as, this should have been written like this, plus or minus 8. Because the square root of 64 is positive and negative 8. However, we can't say x is equal to negative 8, so therefore we would just keep the positive answer. So you could do it either way. So this way works only when there's a solo x squared. You set the x squared by itself and just solve it like that. Alright, and what do we got here? So there we go. Came up with our answers. Alright, so let's keep going on. Might have to speed it up here just for time. So now we can play around with some harder ones. So here we go. There are 2 rational numbers. That means they're fractions or decimals. They have the following properties. When the product of 7 less than 3 times the number with 1 more than the number is found is equal to 2 less than 10 times the number, the 2 rational numbers, or find the 2 rational numbers. Now when I read all that, you're like, what is he saying? So you have to slow this down and take it piece by piece. The product means multiplying 2 numbers. So what are we multiplying? The product of 7 less than 3 times the number So that's one number right there with one more than the number. So those are the two numbers being multiplied is found. That means equal to 2 less than 10 times the number. So that's a lot of stuff going on here. So I'm just going to help you out. Well, if we say let n be the number, let's take each piece one at a time. So we have this 7 less than 3 times the number. That would look like this. 7 less than 3 times the number. You don't have to write all this part down if you want. Then we have, so 7 less than 3 times the number with 1 more than the number. So that would be easy. That's 1 more than the number. Is found to equal 2 less than 10 times the number. That would be 2 less than 10 times the number. So remember, it says the product of this and this. So we would multiply equals this. So when we write that out, there we go. The product of this with this equals that. And so when you read these big things, you have to slow down, look at where things are, the product of two things, look for the separation words, look for the equal signs. Not really easy. So now I would multiply this out. You don't really do it this way. You'd probably just get this step right here. Now this is a quadratic. See that n squared? So that means I have to set it equal to 0. I would combine like terms here first, so we probably did that. There we go. A little extra work than you need to. Then I'd set it equal to 0 by subtracting the opposites over here. You end up with this right here. So now you should be able to factor this. This is a leading coefficient greater than 3. That's kind of hard, but we'll just give it to you to save time. Now we take each of the factors and set it equal to 0. And then you'd solve it. And we come out with n equals negative 1/3. And then you take the other one, and there's that one. So find the two rational numbers that fit the description. So there are two possible answers. This is a rational answer. All right, so we are running low on time, so I'm going to go kind of fast. So keep along, and if you need help, ask for it. Remember consecutive integers, we talked about that. That's like the numbers 1, 2, 3, 4, 5, or we could say things like consecutive even integers like 10, 12, 14, 16, and so on. So find all sets of two consecutive integers such that their product, multiplied, is equal 8 less than 10 times the smaller integer. So you should set up some type of equation or expressions for each. So let the first integer be n. So the next one would be 1 more than that. So the next one would just be n plus 1. So first number, second number. The product of these, so n times this would look like that, is equal to 10 less than the smaller one. So, I'm sorry, 8 less than 10 times the smaller one. Kind of going fast. Then distribute this, do the math you know. When you distribute, oh look, n squared, that means it's quadratic. Set this side equal to 0. So subtract 10, add 8. So we're just doing the opposites there. Okay, so now we have it set equal to 0. Now we have to factor that. That's pretty easy. Negative 1 and negative 8. So that should be a pretty easy factoring. And now let's take those and set them equal to 0. There we go. And we could write this in. There is two possible answers. So 1 and 2 or 8 and 9 fit the description. All right, and I believe there's one last question. So what I'm going to do is I want you to hit pause right now, read the entire problem, and see if you could come up with the answer on your own. So give it a try. Really try it right now. All right, so he claims that the number 5 has a property of the product of 3 less than it with 1 more than it is the same as 3 times 1 less than it. So a lot of words. Hopefully you took your time in there. Let's look at some expressions we have here. So notice that we have the number 5, 3 less than it, 1 more than it is equal to 3 times 1 less than it. So we put some numbers out and did it true. And then here we go. Now we're going to use the variable n just to do the exact same thing. You're going to multiply stuff out. Okay, again, you probably skip the step of distributing here. Combining like terms. Oh, quadratic, set it equal to 0. There's our quadratic. Factor it, GCF first, guys. Don't forget that. Then set each factor equal to 0. Sorry that I had to rush that last problem. Hopefully it went okay. And we'll definitely help you in class if we need it. Oh, and the answer to it is where you left it.